Hi, this lesson is about dissociation. We will be talking about how dissociation works in ionic compounds. The learning target for this lesson is that you will identify the ions that make up different ionic compounds so you can write dissociation equations. When we write dissociation equation, there is an ionic and net ionic equation. So you know you got it when you can actually write ionic and net ionic equations. How the dissociation works. What is the concept of association? When we take any ionic compound means a compound of a metal and a non-metal. In this metal-non-metal combination, we know we have a cation and anion. When we take this ionic compound and we dissolve it in water, okay, so you put NaCl in this tablespoon of salt. So water is polar. We will discuss that later in the year. But because of the polarity, the negative end of the water will pull the positive cation of the ionic compound, and the positive end of the water will pull the negative anion. So it will split it. So basically, when the salt is put into the water, it will split into its cation and anion. And that process is called dissociation. It is not a chemical reaction. It's a physical property. It is not a chemical reaction at all. So all we are doing is, when we are writing ionic equations, we are assuming that we are dissolving these ionic compounds into water, and water is splitting them into their ions. The process is called dissociation. And water will only dissolve something that it can split into ions. If water cannot split it into ions, it will not dissolve it. So all we are doing here is we are going to split it. I have to recognize which one in this formula is a cation and which of the one is the anion. So I know that potassium is a cation with a charge of +1, and this is bicarbonate, hydrogen carbonate. It has a charge of -1. So this dissociation of ionic compound, the splitting of ionic compound into its ions, is called dissociation. So now I have two ammonium ions here. This is ammonium polyatomic ion. So I have two ammonium ions here. Each ammonium ion has a +1 charge. And I have one oxygen anion here. Each oxygen has a -2 charge. So that is all we are doing when we are dissociating it. Now this beryllium has a +2 charge, Be, and nitrate has a -1 charge. And according to this parenthesis, I have two nitrate ions. So total ion I am producing here is two, one of each. Here total ions you're producing are 3. Here one molecule of this is producing 3 ions. So more ions any compound can give you, the better conductor it is, better electrolyte it is. So if I have to decide who will be the best electrolyte of the 3 substances that I just discussed, these two would be the good electrolytes because they are giving you more ions per unit, per molecule. For example, here, look at this one. I have 3 magnesium ions. Each magnesium has a +2 charge. I have 3 of those. So I have 3 magnesium ions, and I have 2 sulfate ions. Each sulfate has a -2 charge. And I have 2 of those. This 2 is telling you have 2 of those. So altogether, we have 5 ions. That means this is the best electrolyte in this on this list as of now, because it is giving you maximum ions. So that this is how we work on the dissociation. So if we keep this in mind, we just continue doing this. We continue practicing it, and just split the ions into their cations and anions. So if I keep doing this, I have 1 hydrogen ion and 1 chlorate ion. I have 2 lithium ions and 1 sulfite ion. Again, I told you by the number of ions that I get, like 3 + 2, 3 cations, 2 anions, 3 + 2, 5 altogether. That means this is the best electrolyte as of now on the list, as we discussed. So let's talk about again what dissociation is. Dissociation means when a chemical compound separates into its components. So we take an ionic compound and when we take a spoon of this, a solid, S means solid, okay, not a gas or a liquid, and you dissolve it in water. This is water, aqueous solution, and it will split into these two aluminum ions and 3 oxide ions. Okay, this is dissociation. It is not decomposition. So let's talk about ionic equations. You take lithium chloride, ionic compound lithium chloride, and you split it into lithium ion and a chloride ions, and you see it is giving you 2 ions altogether, one of this and one of this. And you have 2 potassium ions. This 2 is telling you have 2 potassium ions and 1 oxygen ion, so altogether you have 3 ions. 1 calcium ion and 2 fluoride ions. So the more ions a compound produces in a solution, the stronger the electrolyte it is. Okay. So how do we write a complete ionic equation? Write a chemical equation showing a dissociation of the salt in aqueous solution for both reactants and products. We must understand the word solid means, S means solid, G is gas, L is liquid. And when something is solid, it means it is insoluble. When something is insoluble, it will stay as a solid. So we will not split anything that is solid, okay, unless we put it into, unless it's on the reactant side. So how do we write an ionic or net ionic equation? So if I have AgNO3, silver nitrate, and I have sodium chloride, and it will produce silver chloride, which is solid. That means it is not soluble in water, and sodium nitrate. So I have to look into the solubility chart. You will be given solubility chart on the test. So that means aqueous means I will split it into ions. This you will split into ions. You have a solution of this, you have a solution of this. A solution means when you have a solution, that means it is already split into ions. So a solution of silver nitrate, a solution of sodium chloride, that is giving you silver chloride, it's a double displacement reaction, and it is giving you sodium nitrate. So you see silver is silver ion, and this is your nitrate ion, then sodium ion and the chloride ion. So the one that is solid, that is insoluble, we will not split it, and then sodium and nitrate. And then I'm going to cancel my common ions. Common ions are called spectator ions. So I cancel my common ions and I bring the rest of the equation down. So silver and chlorine on the reactant side will give you your product. So this is your net ionic equation. So this one is your ionic equation, and this is net ionic equation. So let me clean this up a little bit. So once again, this is your ionic equation, and this one is your net ionic equation. So if I take sodium phosphate and calcium bromide, it will give me sodium bromide, okay, sodium bromide plus calcium phosphate. Now I have to see which of the two is not soluble, and that will come from the solubility chart. Let's look at the one. Okay, so let's do this one. It's already giving me the information, so let's go on this one. So lead 2 nitrate means PbNO3 parentheses 2. This is lead 2 nitrate. And this is potassium iodide, that gives me PbI2. And you see this is solid, so I'm going to not split this. And this is KNO3. So now I have to balance this equation. So I have 2 nitrates and then 2 of this. I think this will balance it. So my first job is to make sure that I dissociate all of them. So Pb plus 2 plus 2 nitrates. You know, this is, you have 2 of the nitrate ions. And I have to put AQ, that means it is dissolved in water. I have 2 of these. This is what is important. You have 2 of the nitrate ions. And then you have 2 of the potassium ions. And you have, this 2 all applies to both, right? And I have 2 of the iodide ions. So all of this is dissolved in water. Now on the other side, in the products, it says solid. So I will not split anything that is solid. Something that is not soluble, I will not dissolve it. And then I have 2 of the potassium ions and 2 of the nitrate ions. So I will split these. Now I will cancel, this is my ionic equation. This is my ionic equation. My next step is cancel spectator ions. Means there are ions on both sides. So I have nitrate here and I have a nitrate here. Then I have a potassium here and I have a potassium here. So I cancel the ions, there are ions on both sides. So what is left is lead plus 2 iodines. It has to be balanced as well. Okay, these are aqueous. And then it is giving me PbI2, which is solid. You know, it has to be balanced equation. 1 lead and 2 iodines. So this is my net ionic equation. And this question will be on the test, so it is about ionic and net ionic equation. That's all the dissociation is. I hope you understand it. Thank you. Bye.